It's a tiny particle containing kind of temperature responsive materials, and that can be dried down into kind of a pigment that can go into other types of products.
Hi, and welcome to another episode of Raw Green, a show produced by Obi, your sustainability consultancy specializing in life cycle assessment, research, and green tech. Check us out at oneobi.com or connect with us on socials. Links are ready for you in the description. Ciao! When it gets hot, and this summer is proving to be a sizzling one, our answer is usually simple. Switch something on. Fans, air conditioning, cooling systems. And we know how the loop works. More heat, more cooling, more energy demand, and then repeat. But maybe that is only half the answer. Because before we build more capacity to cool our buildings, we should probably ask why they need so much cooling in the first place. Today, we're joined by Molly Allington, CEO and co-founder of Albotherm, a climate tech company developing a heat-responsive coating that changes with temperature. Clear when it's cooler, reflective when it gets hot. It's not a new way to generate energy, it is a way to waste less of it and to help buildings cope with summers they were never designed for. Molly, welcome to Raw Green.
Thank you so much for having me. It's really exciting to be here.
Hi, Molly. So we've built ourselves a world full of glass, haven't we? We've got offices and homes, schools, greenhouses, we're growing all our food. And we tend to focus on the double, triple glazing to keep energy in. But as our summers are getting hotter, is all this glass suddenly becoming quite a difficult part of the decarbonisation of our buildings?
I think definitely it's something that it's been predicted, but I think we've been ignoring, particularly in this country, in the UK, where we're used to having to worry about getting cold in the winter, and it's just been the last few years where summer temperatures are so unbearable. But it's very easy for that to get forgotten about. For the last however many hundreds of years, building regulations have been focused around insulation, keeping the heat in. Only been since the last kind of 4 years for the first time that overheating has even been considered in terms of the regulations, and there's still kind of a really long way to go. Definitely seeing a flip where we're going to start to be using more energy, just as much if not more energy for cooling than for heating in this country, which very normal growing up in India, the Middle East. That's kind of part of day-to-day life, but it's not something where particularly in homes in the UK, air conditioning isn't something that we just have installed, and it's not cheap either, nor is it good for the environment, as Francesco is saying in his introduction.
Yeah, absolutely. So air conditioning is obviously in the headlines at the moment. But tell me, what has Albotherm actually built?
So we're a materials startup. So we are designing coatings, films that go onto glazing that essentially allow a building or a greenhouse, as we've historically worked with, to adapt to kind of work with the sun and adapt to the weather naturally. So we have a kind of specialist additive that turns reflective white as it heats up. It's something that we have adapted into a couple of different types of products. So we have a spray coating version. It's all retrofit as well. I think that's probably one of the key, most interesting things about our technology is other kinds of dynamic materials typically are very hard to install. They require kind of electricity.
Expensive.
It doesn't open it up to the market, and it means kind of the impacts that you can make as a business and on the environment is going to be a bit limited. There'll be certain types of buildings that are just never going to be able to kind of install these glasses, which are cost hundreds of pounds a meter squared. So we're looking to do something that it's more affordable and kind of more natural. It doesn't require any electricity and can be installed into any home or office quite simply.
So it's a spray coating for the sake of greenhouses and sort of large areas, and then you've got a film for the smaller areas like windows and panes of glass and things. So you say it gets to a certain temperature and it kind of turns white, turns opaque, and then it turns back again?
Yes. So
and then it turns back and forward and back and forward, and it can keep going the whole time. It doesn't wear out.
So it will turn back as it cools down again.
Right.
So that is it will just be kind of naturally responds to temperature. It doesn't, it doesn't require anything else. We're still assessing the kind of lifetime, but we've seen cycles of it shifting. We've had materials around for quite a long time, and we've seen samples of it shifting kind of again and again, hundreds of times. Depends a little bit on kind of where the product is, weathering and things like that. So that's another good reason, I suppose, for us. Just strategically as a company, we focus on retrofit because it's very easy to install and uninstall. Which, when it's a new technology, untested, that's something that is important. We're innovating a newer version all the time, and want to be able to kind of put our best foot forward and adapt with also the changing needs of kind of the customers and the climate and kind of the building itself.
So,
Sorry, Molly. I'm just curious to know how is it made, and please feel free to disclose any confidential information about it.
Yeah, sure. So yeah, I'll tell you everything. But we produce a special additive in our labs in Bristol. So we're manufacturing that ourselves at the moment. What it is it's a tiny particle containing kind of temperature responsive materials, and that can be dried down into kind of a pigment that can go into other types of products. So into coatings, into films, any kind of like transparent sort of products. So we're putting them into window films now, but historically it's been sort of a water based but paint basically.
Okay. What physically happened to the material to switch from transparent to white and reflective? What happens there?
Um, so it's actually what we make is an additive with kind of liquid core, and
Okay.
it's a polymer dissolved in solution, and when it's completely dissolved, it's completely transparent. And at a certain temperature, it becomes unstable, crashes out, and it's the fact that you now have kind of separated polymer and solvent within the
ooh.
center of this particle.
So it's like a sort of an ice. It kind of freezes at a certain temperature, goes that slightly more misty opaque color, and then
Hmm.
kind of
Mhm.
thaws back out into the water and freezes again, obviously at completely different temperatures and things. That's
Yeah.
fascinating.
So yeah, it has completely the opposite kind of behavior to what you'd expect. And interestingly, my co-founder was looking into it for completely different applications, biomedical applications, because it does this kind of shift around body temperature, and that there was like different ideas of what they might do with the materials. So
Oh,
the
interesting.
fact that it was turning white was just kind of a side effect, basically.
Oh, I love that
And
about innovation. This is the
Yeah.
post-it note story all over again, isn't it?
Yeah,
yeah.
that's fantastic.
Wonderful.
Can you decide the temperature at which it switches? Is it a way that you can tailor that? Because obviously,
Mhm.
then the number of application can increase exponentially.
Yeah, definitely. It's very tunable. It's quite easy for us to tune. We've kind of been able to
Fantastic.
do that up to 45, kind of even maybe 50 degrees. We can tune to any temperature. We've gone down to sometimes we have ones that are white at room temperature and you put them in the fridge and they go cold. So we can also do the other end of the spectrum. So that's very tunable kind of at the point that we manufacture the materials.
That's
Fantastic.
fascinating. So you
Yeah.
started with greenhouses. I can imagine why, but tell me about that journey in terms of where you identified the initial customer need and what farmers and growers were specifically looking for when you first started talking to them.
hmm So I suppose the idea for the product initially came from conservatories. So there's a big glass
Okay.
box in people's
Mm.
houses. It's
Always too
overheating.
hot or too cold. They're never
Yeah,
just right, are they?
100%. So that was
Can you
where
please
we kind of
explain for our non-UK listeners what is a
What
conservatory?
is a
Because I really
conservatory?
think
okay.
that it is a place for nuns, or it
Yeah.
is I don't know where you play music. But
It is
can you?
it is a room that you put on the side of your house in England because you
Yeah,
have this wonderful vision of springtime and autumn time where you want to sit outside but it's a bit too chilly or a bit too windy, and therefore you can imagine sort of being half in half it out, think verandas and things like that, but they are glass boxes, as Molly says,
Mhm.
and they are
yes.
always too hot. And the one day of the year that they might not be too hot, they'd get too cold. And, I have always been a frustrating point for anyone that's owned one, haven't they?
Yeah, that's exactly it. And so yeah, so our research supervisor was the person that had one, and it was pretty much unusable, and so that was where the idea came from. But then we started to, I guess, do a bit more market research and look into other types of places this could be applied. Um, Conservatories is, I guess, a relatively like smaller market for us.
Hmm.
And so when we saw greenhouses having the same kind of problems with overheating, but it's a big industry kind of producing food. That was what really stood out to us. That one of the ways that they get around it at the moment is they just apply a white paint to the roof of the greenhouse for most of the summer, and that is kind
Mm,
of really standard practice within the industry, which is seems quite mad, to be honest, that that growers were kind of going to that much effort every year to kind of sometimes hand apply this paint onto the roof of their greenhouses just to stop the plants from kind of like cooking in the summer.
Mm.
Um, and then they would remove them again when the weather cools off. So very kind of labor intensive process, but ultimately farmers just need to protect their crop.
yeah.
And you
Yeah.
don't know how hot the summer's going to be, if it's going to be heat waves, or if it's going to rain for June, all the way through. So
And
we
how
found that.
effective is it actually at preventing overheating in terms of the white paint or your solution? Is that enough, or do they have to do other things as well, given where we are?
Yeah, so it does make a really big difference. So,
Okay.
one of the best ways to control overheating is to reduce solar gain. That's kind of the simple answer is don't let the heat in the first place. There will still be some kind of heating, in particular if it's really hot. Growers will always rely on natural ventilation as well in some way. Even if it's not too hot, that's just important for humidity control and kind of keeping plants healthy.
Very true.
But what they can't afford to do within this market is use air conditioning or some kind of active cooling, which is actually removing heat.
Mm.
So it's all
Yeah.
about kind of preventing it from coming in and kind of, making the environment kind of more naturally and more affordably comfortable for plants and for workers as well, because, people have got to be in there looking after the plants and harvesting and doing all of those jobs as well.
Molly, give us an idea in terms of numbers. What kind of variance in temperature we can expect with and without your Albotherm coating on top
Yeah, so we've
on
done a few different.
greenhouses specifically? Yeah.
Yeah, we've done a few different trials on greenhouses, and so we've always trialed against another kind of competitor product rather than against greenhouse with nothing, because that's what the farmers are already doing. So, for example, a trial that we did on a blackberry crop, we were comparing to a product that has infrared reflective materials within it. So they're designed to let in a bit more of the visible light, which the plants want, but to protect from overheating. And on the hottest days of the year, we were about 6 degrees cooler
Mm.
than the
Wow.
crops under this coating. So that was really, really significant. Like I say, we didn't trial against no coating, but I imagine it would be kind of even more significantly higher if it was against a greenhouse without any shading.
And how does that affect yields and things? And therefore, obviously, the sort of return on investment that farmers are looking at.
Mm. Well, as soon as the plant kind of reaches over a certain temperature, it's just putting all of its energy into survival mode. So there's not going to be kind of anything particularly going into producing fruit. It depends on when it happens within the lifetime of the crop, but we've seen yield increases of up to 34% with our product, just compared
Wow.
to kind of other competitors. So can be hugely significant. And for a hectare of growing, that could be £300,000 worth of extra yields that growers would be getting from that kind of an increase.
That's amazing. Well, you do have a variety of competitor technologies that offers similar, let's say, solutions. You mentioned the white paint earlier. You can do nothing basically and just let the heat inside. I know that several farmers use solar panels with a particularly tuned wavelength that is being tailored for a specific kind of crops inside. So there is always this need, obviously, to compare to see which one is the best solution for that particular farm, but also for that particular latitude. Okay, because maybe
Hmm.
the farmers in the UK will have different needs compared to the one in, I don't know, southern Mediterranean countries. While the greenhouses are definitely an important market, there is another one. I would like to ask you something that it is multiple times bigger than the greenhouses one, which is the built environment. Okay,
Hmm.
and we, as I mentioned earlier, the cooling of the buildings, our buildings, that they were never been designed for this kind of temperatures. It is an incredible chunk of energy already now and projected to be even bigger in the next couple of decades with the addition of a number of things. So I'm curious to know, how does Albotherm fit into the built environment? Is it just about the
Hmm.
cooling, reducing cooling demand, improving comfort, compliance? Have you worked your angle already around the built environment?
It's something that is just the market that we always wanted to go for. It's obviously a huge market. It's global, and it's where we think that we've always felt our technology would have a really big impact. We have only recently started to kind of develop products specifically targeted at this industry. It's definitely a challenging one to approach because the regulatory space, the kind of requirements of customers is very high. But I think that we see that our technology is something that is very unique within the market. So there are hundreds of window films out there, solar control films that are already designed to kind of tackle the overheating in summer. The biggest drawback of them is that they're always going to be a kind of fixed solution, what's out there already, and
One
what
way.
our product is. Yeah, exactly. So you always create that kind of trade off, which in certain countries where it's hot kind of most of the year, you might that's in your favor potentially to kind of accept that trade off when it's cooler. But a lot of the globe is more temperate, is more changeable, and even now we're seeing that climate change. The winters aren't necessarily. We still get cold winters in the UK, but we're noticing that weather is less predictable. It's more variable. We're getting higher highs and lower lows, and kind of more periods of um, like snow in times where you wouldn't expect, and then suddenly raining. So
It's a
um,
good point here in Britain, isn't it? Because we've all got very short memories. We're sitting here quite hot and sweaty in the summer
mhm,
right now in July, but come November we'll want that sunlight coming in and warming us again. You know, the nice days that we do have are valuable, and many of us have sort of got our houses to make the most of that free additional warmth as and when we can get it. So how does your film sort of compare to the competitive films that are out there at the moment with regards to that adaptive element? Talk us through a little bit more detail, because we're all looking into solutions right now, but we'll forget come winter that
mhm,
we don't want a permanent solution that puts us in the dark.
yeah. So I guess the way that you typically assess these kind of products is based on G value. So
Okay.
that's a way to kind of say how much solar gain is getting into your windows. So in summer you want it to be as low as possible. In winter you want it to be higher. And that's the thing that's really interesting that our product is doing, is that it's changing its G value depending on the outside conditions. So you get a kind of a 10% change either way, depending on it kind of if it's in the maximum cooling state where it's kind of shading as much as possible, or if it's in the state of being kind of as close to glass as possible, where you're really blocking a very minimal amount. You can see through it, and the product is kind of essentially looks the same as and acts the same as
It's
if it was
invisible.
just normal glass. Yeah.
Amazing.
What kind of again, also here, variants we can expect in terms of load, thermal load on the AC? Is there a ballpark figure there?
So I think again, what we've kind of done so far, we haven't put this product up kind of in a building just yet to do these tests in
Mm,
real life.
okay.
But from kind of what we have been doing is looking at similar products and how they have performed. So similar in terms of the G value that I mentioned at kind of our maximum. So what is if there was a film that is doing that fixed all the time? How well is it doing in summer? And how well is it doing in winter? So we'd imagine quite similar summer savings in terms of air conditioning, which kind of is, up to about 30% in kind of
Wow.
countries like in the UK, um, and can be kind of slightly more if we're talking. I've seen 50% in say the Middle East. Um, but again, it's about kind of finding that trade off because when it comes into the winter where you start to see problems is you're not allowing the kind of natural solar gain. So you again can be between 15 and up to 50% of kind of wasted energy that we would be able to save. So that's if you're looking at kind of what would nothing be doing and what would this other kind of product be doing. It can be a really significant kind of year round difference.
Well, the UK, especially during the winter, you want to be able to capture those hour and a half of sunlight that you get from
Yeah,
the end of September until the end of March. I loved your
definitely.
positivity earlier, actually, Em, that you said November. What November? Here, the bad weather starts at the end of August already. So,
Oh, it's not that bad. But listen, I'm seeing huge potential for this, particularly with our public buildings. You know, schools, hospitals, they
yeah.
struggle with this kind of stuff enormously, and people's comfort within those buildings is really really important. They're built so badly that a retrofit option is pretty much all we've got available. How does it work, sort of cost parity wise, to other films and other solutions and things, Molly? I appreciate it's early in your journey, but are you hoping to come out at cost parity with other films, or is
hmm
this always going to be a slightly more expensive technical option for those that can afford the smart, sassy cleverness of it?
Yeah, for sure. I think that we think that we'll be able to be cost competitive with other kinds of like high tech kind of films. So it's probably going to be slightly expensive than other like basic films because that is
The
kind of a
grey tinted ones that are just
yeah, just
standard.
that's
Yeah.
just the simple thing that's on the market. But we definitely think that we're going to be in the tens of pounds, and not the hundreds of pounds. So, orders of magnitude lower than say something like electrochromic switchable glass, which can be £600 a meter squared, and you have to replace your whole window unit, and you have to have downtime on the building, and that's just not going to be possible for
No.
a lot of customers, and particularly for kind of areas where that the glass that's up there might be less accessible. You can't really kind of install a whole new window unit very simply. So
Yeah.
we see it being a kind of bringing that additional functionality, but at a more kind of reasonable price point.
What's the duration? Is there a performance decay after a certain amount of time, or does it stays forever?
So at the moment, it's a product that's very new. We've only had it for a few months with this film. We've had samples outside where we haven't seen any kind of any issues over the summer. But we are putting them through accelerated aging testing. So
Yeah.
I haven't got an exact number right now where I can kind of make a warranty that it's going to last a certain number of years. But I think that we are definitely looking at kind of multi-year use. And
Hmm.
we think it will be, really possible to get kind of longer term use out of the technology as well. I think it is one of the downsides switchable materials as a kind of an industry in general is lifetime can always be a little bit of a technical challenge to overcome, but I think we're seeing really promising results at the moment. So just need
It's a
to
challenge with anything that you put on the outside of a building, that it's got to withstand the
Yeah.
hail and the rain and the temperature changes and pollution and
Mhm.
sort of chemical interferences and things like that. So I totally understand. In fact, sunlight itself is probably one of the biggest degrading factors that you're going to have to work with. But I would be assuming at this point that technically it doesn't just stop working. You're just looking at a sort of a slight devaluing perhaps of it over time, and ultimately you
Mhm.
would want to replace it for a nice fresh application later on. So I can still see that it would be really, really attractive to, like I say, the hospitals, the schools, those that have the smaller budgets, but potentially can maintain that a little bit better.
Yeah, absolutely. I think, people should be able to see return on investment fairly quickly with something like this. So if it's something that it's not necessarily gonna last for decades, but if it's lasting for a few years and you're seeing that return on investment, then being able to easily remove and reapply it is something that we're kind of
Yeah.
designing into the process.
Yeah. Are you seeing
And
any sort of regulation or policy that's starting to catch up with this kind of thing?
there is a little bit of regulation. So within the kind of like home, like residential, I guess, building space, that's probably the most regulated part of the market. So there is something called Part O regulations, which is overheating. Um, that is like an area that is becoming more and more of a focus. It's only been in place for the last few years. And it's the first time that building regulations have required overheating assessments to be done on any kind of
Oh,
new builds.
I was going to say new
So
builds only, right? Not
yeah.
not obviously retrofitting. Okay.
New builds only, yeah, or any kind of significant enough refurbishment project, but
Okay.
it is largely kind of limited to new builds at the moment, and kind of commercial buildings don't have the same restrictions either, and they tend to have a lot more ability to
Oi.
you can get around overheating risk assessment by putting in air conditioning and by
Yeah.
spending a lot of money and spending a lot of
We
energy
we
to
both
just take the
flinched when
out.
you said that. Both Francesco and
Mm,
I just went, "Oh,
mm.
commercial buildings are not," because of course they're built by people that will never have to work in them or be in them, and they're never held
Yeah,
accountable for any of this. And of course, they won't be paying the energy bills either.
no,
Um,
Definitely, yeah.
n-
But I think
no.
I think it's we're getting a lot of interest from just home buyers in the
yeah.
product at the moment, and a lot of people that are really struggling with overheating. We've got someone that I've spoken to who has a kind of glass pitched roof, and they're seeing that flies are literally dropping out of it because
They're
it's kind of the air
suiciding.
up there is
Yeah.
yeah is
So
is
hot.
Good
is 40
lord.
plus degrees,
Good
and
lord.
it's not sustaining life.
No.
So it's starting to become really dire for people. I think they're desperate for something that will be able to solve those problems quickly. I think for commercial buildings, I don't necessarily see we have more forward thinking kind of building managers, but really for us for that market, we need to be able to prove the energy savings in very definitive
Yes.
terms before
Very good.
it's of any interest, or
Numbers talk,
regulations need
bullshit
to be
walks.
brought in.
100%.
Or it's
100%.
just going to be a pain point that forces people, the south facing wall of a building that you just can't do anything else about. If you're a primary school and you can't afford the air conditioning, but there's a part of the school that's perpetually,
Mhm.
under threat, sort of, under attack by the summer,
You start from
it's going to
there,
be
and
necessary. Yeah.
you start
Yeah,
from there,
and
and then you build up.
yeah,
It is inevitable. So
One solution. Yeah.
it is not just about comfort here. We're talking about
mhm,
health
yeah,
concerns, health and
Mhm.
safety. We're talking about adaptation. We talk about the energy side of it. We talk about the comfort side of it. The other part that we wanted to talk to you about, it is exactly this, the adaptation side of it, because with the rising temperature, I got this data from the UK climate change committee. They said half of the existing UK homes are already at risk overheating,
mhm,
and okay, we got that. That becomes 90% if we reach the 2 degrees scenario, which is very likely, and all existing UK homes are going to be under overheating stress if we reach the 4 degrees scenario. So
And
what
only
we talk about
2%
here,
of us have air conditioning as well.
yeah, now it's 5 or 6% since the past couple of weeks. But
yeah,
this is where it gets bigger than energy efficiency, because if offices, homes, public buildings, and everything are reaching unsafe temperatures, cooling it is no more a comfort thing, but becomes a public health priority.
yeah.
So have you thought about that as your technology as a vehicle for adaptation? So
As a
it's not
marketing
big.
message.
Definitely, yeah.
No,
I think
yeah,
the
positive, but
public health is becoming a much bigger part of the
It is.
conversation. I think for the last couple of years, the the heat waves are becoming record breaking and like the new normal now. It's like we're just having one every single month in the summer, and that's just part of it. So I think particularly for vulnerable people,
There you go.
or
Yeah.
kind of for children, for older people, disabled
Hmm.
people, it's already been kind of significant. So we're really trying to kind of reach out and to be able to work with kind of local councils and authorities, to be able to get into kind of those buildings where you'd be able to make a difference to those people who need it most. So definitely, again, it's kind of the sad truth that it's we're noticing that this is people are more interested in something like what we're developing because of all of this that's going on. We've been talking about this for the last 5 years, and people thought it was a very cool idea. Like, pardon the pun, but there wasn't quite the level of like
I
urgency
just got
to
it.
it. Yeah, not quite the level of urgency to
I
it
do appreciate a
as
good
we've had
pun.
this summer. Yeah.
Sorry, silly of me.
But
But
well, I still want to. I mean, it feels unnecessary to talk like this, but of course, you're building a business and you're going to be doing this at scale. I
Mhm,
foresee you're going to have a huge market. So it does mean that there's an environmental cost to what you're actually producing,
mhm,
a footprint to producing the films, to producing the spray on chemicals. You mentioned, I mean, let's cover both of those, but let's go back to greenhouses quickly and just talk about that spray on solution, because it's obviously a temporary solution for summer that you say gets washed off basically for winter. Just tell me what's in the solution that is ultimately being washed off into the ground that we are then obviously hoping to grow our food from.
mhm.
And then we'll move into the building side.
Yeah, for sure. So, like with any product, there's an environmental footprint attached to it. So, what is I think people don't realize that paints are, well, they're made from polymers and they are a plastic. So there is that kind of side and that risk to them. They mostly are petrochemical based. It is possible to kind of make paints from like renewable resources as well. And we do use a lot of renewable kind of materials within our products, but it is difficult to make them kind of 100% from those kind of sources. It's hard to get the right kind of material properties to give the benefits and everything to the crops, and there also just isn't as much of a readily available supply from suppliers, and kind of cost factors as well can come into it. So there is, we there is a risk with washing off these plates that you are putting kind of sometimes microplastics into the environment.
Yeah.
And I think we one of the projects that we've looked into over the last few years, Innovate UK funded project, is to look at ways we can mitigate that with either changing the materials that we make from, changing the way that we kind of remove and collect the products afterwards to create kind of recycling system. Um, or making them completely biodegradable, which is also something that we are kind of looking into as well. But it's challenging to do alongside making the products work
I've just
as
caught
well as they
myself on this,
can.
Molly, because of course I've asked you as if we're going to be washing off the Albotherm product once a year, like they are with paints, like business as
Mhm.
usual currently is. But of course, the suggestion with your material is that it won't need to be washed off because it will go back to being see-through again, and
Yeah,
therefore, yeah. So I guess there's an environmental benefit to be had there if you're just reapplying occasionally and not doing all of that seasonal work.
yeah.
So coming into the film side of things, for buildings, obviously you're looking for production now. Is there anything that goes into this product, this material, that is considered rare or dangerous, or anything that has got an environmental concern itself?
So the kind of the core materials that we use, and what is the kind of the interesting part of our materials is a very safe material. So we do use a lot of, like I say, kind of bio-based polymers. They're non-hazardous in and of themselves. So then they aren't kind of horrible, nasty materials
Yeah.
where you're going to have really high risks of toxicity. But yeah, the idea with our product is that ultimately you would be able to kind of use it for multi-year purpose, which is not what is the kind of industry is able to do right now. So think that the longer and longer we can improve kind of durability and lifetime, then the better the environmental impacts are going to be.
What has been the hardest thing so far for you? Has it been developing the product? Has it been the, let's say, you now have to ramp up production, but has it been the manufacturing so far, or also the
Okay.
communication side of it, the education,
Mm.
market education? Which one has been the hardest part so far?
I think that the market has been really receptive to the product, and I think one of the things that we benefit from is that it's so easy to explain and to understand. But
Mm,
where the challenge comes for us as a startup is getting the proof points that we need and getting them quickly. So all of the first things that you said, they're all kind of tied into that. So
yeah,
the manufacturing, the R&D, and doing the crop trials is
science, data. Yeah,
yeah. There's a natural amount of time that you have to spend on them, and they are seasonal, and we have to say just to do a small greenhouse trial, we have to figure out how we're going to make 100 kilos of something to cover a
yeah.
couple of thousand square meters, and
To
that's
manufacturers, then maybe they have minimum orders of a few
mhm,
tons. Yeah, yeah. I know
yeah,
that's not easy.
definitely.
Yeah,
So that has been something that is, taken us quite a long time to be able to kind of get the production up to a point where we can, give out large samples. And, until that is done, we're not able to get the kind of the proof point that we need to
of
just to
course.
launch a product commercially. So that is that's always the slowest part of the process. And I think it's one of the exciting things about also working with the buildings market. It can be slow and there's regulations, but actually it's quite quick to see if it's working, and it's quite quick to iterate then in a kind of to improve the product, improve the response, and get a better product ready for market quicker.
And what's
Yeah,
the
good.
next bottleneck that you see coming down the road?
I think that we're going to have to kind of get our manufacturing up to commercial scale. We've
Yeah.
taken it up to kind of a pilot scale at the moment, but to get it up to kind of actually ton level production, and also for this newer product, which is slightly different again. So it's going to be a lot more um, I think complicated to work with a varied market and kind of get everything in line for that. I think that yeah, the buildings market is there's a lot of players, and it's very competitive,
Oh yeah.
which does represent very different types of challenges, and we're going to have to kind of move really quickly as soon as we have something out there.
Yeah. How long are Francesca and I going to have to wait before we get to buy a roll of film or so for our back windows?
Hopefully not long. I think we are hoping to get things lined up to have something ready for people next year. So
Oh, amazing.
we've
There we
we've
go.
got a few people on the wait list already, but
Bet you have.
definitely keen to hear from anyone who would love some for their house or their building, because we're talking to suppliers, and we're hoping to kind of start planning for orders for next year.
Awesome.
Fantastic. Fantastic. Thank you, Molly. I do like this a lot. I am a big fan of energy efficiency in general, of anything that it is able to save or avoid misconsumption. They tend to generate the biggest returns, the biggest IRRs, but they tend to be overlooked in favor of the energy production. So I am deep in favor for more technology like yours, truly, because they are simple. We briefly touch about the retrofit market, but retrofitting anything around the world, it is incredibly expensive. So if you have a solution that it is cheap and effective, I do not see why it shouldn't be incredibly successful. So I thank you for being with us on Raw Green, and I really, really look forward to have your coating on one of my windows very, very soon. Okay, ready for the next heat wave and summer.
I do. I do. I'm joining
Yeah,
your wait list, Molly.
Yeah, don't worry, you'll be right at the top. So no, it's been really great. No, thanks so much for having me.
Thank you for joining us, Molly. Take care.
Thank you, Molly. Take care. Ciao. Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!